All right, good afternoon, everyone. Today we're going to be talking about 3D printing. Now, I tried to get a camera set up so I could actually record my printer and demo that, but I wasn't able to find a camera, and it's surprisingly difficult to get a Chromebook to act as the camera. So what I will end up doing is I will go ahead and record it and then just upload it and send a link to everybody, letting them know that it's there so that you can take a look at that whenever you want. So today it'll probably be a little bit shorter just because I don't have a demonstration, but we're going to talk about 3D printing, the history of it, some different technologies, as well as some concerns and questions surrounding 3D printing. And 3D printing is cool. So I am a huge fan of 3D printing. So any of these concerns and everything, I will play devil's advocate on it. So what's the history of 3D printing? Well, back in 1981, Hideo Kodama of the Nagoya Municipal Research Institute published his account of a functional rapid prototyping system using photopolymers from layers. And so this is the first published idea for a 3D printer. And so his idea, what his research was to basically build up an object from layers. And that's literally what 3D printing is you basically create an object from layers. In 1984, Charles Hull, he's also known as Chuck Hull, he invented what's known as stereolithography. It's a method of using a UV or ultraviolet laser beam in a vat of photopolymer to build up layers. And so what it would do, and this is what his original patent was for, is he had a vat of resin and he had a laser beam, UV laser beam, which would actually shine into that vat at certain points. And whenever it hit a point in the resin, it would harden. And so he would just do that for the entire layer, and he would use a computer to control where the laser was actually supposed to be pointing. And then he would pull that model up slightly. And so now the hardened layer or the hardened model is outside of the liquid. And then he would do it again. And then he would pull it up and do it again. And as he would do that, the new layers would fuse onto the existing layer that was just pulled out of the resin. And then the laser would just harden each new layer. And with that, you can have a 3D object. Now, Charles Hull is he's the father of 3D printing. He's actually the one who owned the patent for this. He also created a file format called STL. STL, I think, might stand for like stereo type. I don't remember exactly what it is, but that's the file, a common use file now for a 3D model. Once you design something in some sort of 3D software, then you can export it as a STL file, and then you can take that STL file and load it up into software called a slicer. And the slicer software is what actually creates the instructions for a 3D printer to understand. But the interesting thing about Charles Hull is he was born in Gateway, Colorado. And he was born there and he actually went to school at Central High School in Clifton. He eventually graduated and went to college back when it was Mesa Junior College, way back when. And he ended up transferring out of there to go to, I think it was CSU. Um, I'm going to double check that because if I'm wrong and I say the wrong school, then somebody's going to get mad at me, and I don't want that. He graduated from, I'm pulling it up, uh, uh, CU, University of Colorado. He received a BS in engineering physics from the University of Colorado. Uh, After that, he came up with the idea. He was working at 3M, uh, and I think it was 3M. Um, he was working at some company. doesn't actually say, or I'm not reading it quick enough, and I don't want to just read through the entire thing word for word. It's on Wikipedia, so you can find it out there. But whatever company he was at, he started developing this, and then he ended up developing it on his own, I believe. And he started a company called 3D Systems. And 3D Systems was founded in Valencia, California, and it was the first commercial 3D printing company out there. And so he's a really interesting guy. I've met him once. He gave a talk, and I was able to listen in on it. But he's he's the father of 3D printing. Then in 1999, scientists at Wake Forest Institute for Regenerative Medicine printed synthetic scaffolds for a human bladder. They took the object they printed, they coated them with human cells so that the body would not reject it, and then they implanted the scaffolds into a patient. And this was the first, I believe it's the first recorded instance of a 3D printed object getting implanted inside of a human in a medical environment. 2005, Dr. Adrian Bauer, Dr. Adrian, created the RepRap project. So the RepRap project was an open source initiative to create a 3D printer that could build itself, or at least most of it. Now, what is key about this date, 2005? Well, if we think back a couple of weeks when we were talking about copyrights and patents, patents have a shelf life on them. Once you have a patent, you have that patent for 20 years. After 20 years, that patent is now in the public and anybody can make whatever it is based off of that patent. Charles Hull owned the patent that for stereolithography back in 1984. That patent expired in 2004, I believe, or somewhere around there. And at that point, that is when 3D printing started to enter the consumer realm. Before this, 3D printing was something that only a few companies had the capability to manufacture the printers themselves, and the printers were quite expensive. But after that, these researchers and individuals, they started to see how they would function, and they started to design and develop printers that the general public use and the general public could make. So this Dr. Adrian Bauer, or Boyer, I'm going to just say Bauer, just for the sake of argument, Dr. Adrian Bauer, he decided that he wanted to have a printer that could manufacture parts to create another printer. And so self-replicating that. And it's not exactly self-replicating. It can replicate a lot of the components, but there's still some parts which cannot be 3D printed. Anything which is electrical, the motors, the hot end, the heated components, those can't just be 3D printed. But the parts of the frame can be printed. The gears to actually move things back and forth, the stuff which the belts and everything hook onto, the actual outside structure of a 3D printer, those can all be printed. And so he created this project to open source 3D printing and to make it available to everybody. And it was actually a huge success. I believe the RepRap project is still, well, the RepRap project is still available, and you can go there and find all sorts of 3D printers. In fact, let's go ahead and look at it really quick. RepRap. So reprap.org is the website. Looks just kind of like a Wikipedia page. But from here, and this is actually what your homework is going to be, there is a list of 3D printers. Build a RepRap. And this has all sorts of 3D printers which are part of the RepRap project. And there are some, well, they're all names of actual printers. You can see the license. Now, thinking back to our copyright, the CC, what does that mean? Creative Commons. GPL, GNU public license. I think there might be an MIT license in here, maybe, or maybe not. Maybe I was just imagining that. But this is Creative Commons, and then let's see, I can't remember the actual what those stand for. But if we click on it, non-commercial, that's the NC, share alike, and attribute it back to the original creator. So that's what this particular one has. So you can make it, you can give it away, but you can't sell it. Whereas this one, you can make it and you can sell it. That's what the license is. So there's a ton of different printers here. And there's also all sorts of software and everything that you can use for it. But all these 3D printers, they all have very similar functionality and they all have um, similar styles. Now, there's many different styles for 3D printers, but I'm just going to go ahead and pick this one. You have your gantry here. You have your hot end. The filament comes through this tube here. This happens to be well, this is a tube. Generally, it's a Bowden tube. Oh, actually, in this case, this is actually holding the wires. This is a direct drive. You have this line right here. This is actually the filament, which gets driven directly to the hot end. You have a motor here, you have a motor here, you have a motor here, and that's what will provide the three-axis of movement, the X, Y, and Z. This particular motor is actually what moves this back and forth. This motor here moves the gantry up and down, and this motor here moves the bed back and forth. This is the build plate. This is what actually you print onto. This can be a heated build plate, so it actually warms up, or it can be a non-heated build plate to where it's just a solid slab of metal or glass or something like that. Right here is the controller for it. This happens to be, looks like an Arduino. Um, I'm not sure the exact ones. If we dig through this, they actually, there's a video clip of it, there's development, these are the actual printed parts. So you could go through this entire Wikipedia or well, RepRap document, wiki document, look at pictures, buy some parts that you can't print. It actually has a list of what you need, and you can build your own 3D printer. It's all completely open source. Now, the cost for it, that is up for question because some of the stuff is more expensive than others. But really, with the patent expiring, it allowed all sorts of 3D printers to get developed, and so that is that's a type of 3D printer. Here's another type of 3D printer. This is a Simpson. It's probably yellow because it's named after Homer Simpson. I'm not sure, but this one has a completely different style. It has three arms here, which the arms basically move this head in the directions, the X, Y directions, and also in the Z axis. And so it's a different style. It's also a 3D printer. It has the same motor here. There's a hot end there. The filament's going to come, it looks like it comes down this area here, right to the hot end, and then you have a 3D object which is printed out. And so 3D printers, several different types, and the RepRap project really brought it more mainstream. Now, I wanted to build my own 3D printer back in 2005 and 6, 7, 8, 9, 10. Well, now I want to build my own 3D printer. I bought a kit. It's a Ender 3 from Creality just because, well, I didn't have the time to actually go out and source all the components and build everything. The Ender 3 kit is an open source um, printer, which I will create a video of it working, but it had all the components in there. I didn't have to go out and find them, and it works decently well. So that's the RepRap project. Since 2006, many companies started creating kits and open source plans for printers, such as MakerBot. That's the link which I went to, which I forgot was on the second slide. So anyway, we aren't going to go back there. But MakerBot was one of the first companies out there which would actually create a kit for a 3D printer and then send you all the components as a kit to where then you could assemble it. So you didn't have to go out and find your own components and source everything yourself. They did all that hard work. They had a little extra amount tacked onto the cost of the components just because they had to do all the work, but then they sent it out to you. Unfortunately, I believe that MakerBot is no longer in business. I think they went out of business a year or 2 years ago, but they were one of the first ones to actually start creating kits that you could send to, or that they could send to you. Nowadays, printers exist in a variety of fields, use multiple types of materials. There are printers which can build houses, which there is a YouTube video which we will see a little bit of it, but not the entire video, where there's this company which is trying to build houses in third world countries, houses in locations where a lot of people don't have houses because, well, it's too expensive or they can't afford a house. And with this printer, they say that they can build a small house in 24 hours. There are also printers which can print metal parts. Now, the metal part printing is a little bit different than the regular plastic printing. And we'll actually see a website which will kind of detail it, but it still builds it layer by layer. But instead of pushing down a layer of plastic, it actually hardens a layer of metal filings, basically, a metal powder, and it hardens it and binds it together, and it acts the same as a stereolithography printing, where it's kind of a vat of, in this case, metal powder versus resin, but it does something very similar. And there's also replacement medical parts, which we saw with the other company which created the what is it, scaffolds in the bladder. Companies nowadays, there's also companies out there which you can make up your own 3D object, send it off to them. They'll print it off in whatever material you specify and ship it back to you. So you don't have to own a 3D printer. Shapeways, I believe, was one of the first ones out there. There's several other companies which I don't know off the top of my head, but at least with Shapeways, and they may have changed, oh, they probably changed it from when I looked at it originally. You would upload the 3D model and you would choose what type of material you wanted. If you wanted it to be plastic, if you wanted it to be metal, if you wanted it to be sandstone, and what color you wanted it to be, and if you wanted it to be one color or multiple colors, how big you wanted it to be, number of copies, and then they had an entire farm of 3D printers that once they got the order in, they would do some work on the model to make sure it would print, send it to the 3D printer, and then ship it off to you. And I mean, back when I started looking at it in the mid to late 2000s, a 3D printer was several hundred thousand or to several thousands of dollars just for a consumer 3D printer. And Shapeways, they could print off a 3D object for you for 20 bucks or 50 bucks, which if you only have a couple of things you need to print it off, there's no point in buying a full 3D printer if you just wanted to print it off. And so they gained a lot of customers and everything. And even now, they're still doing pretty good from what I understand. So, what types of printers are out there? And when I say types of printers, I'm just meaning what technology do they use for printing? What materials do they print? So the first one that we're going to talk about is stereolithography, or an SLA printer. And this is the one that Charles Hull designed and owned the patent for. And so like I had mentioned, it's a vat of resin. And it's a liquid resin, and it would shine a laser in there. The laser would harden wherever the laser hit, it would harden. And as it hardened, it would draw the design, and then it would pull it out, and then it would do the same thing. And eventually you would have a 3D model, which was a hardened resin, and the rest of the vat was still liquid that you could pop off there. And if you wanted to print another thing, You just repeat the process. Then there's digital light processing. And this is very similar to stereolithography, only instead of using a laser, it uses, well, light. So kind of think of the back before there were flat screen TVs, there were uh, rear projection TVs. Or even nowadays, you have projectors where you have a light bulb in there and then it has lenses and it focuses it. It did something very similar to where it would take the light and focus it down to a small point, which would heat up the resin, cure it, and go about its way. The other big printer is called fused deposition modeling, or fused deposit, yeah, deposition modeling, or FDM printer. This is, I would argue, and I would probably be mostly correct, at least according to me, it's correct. This is the most common 3D printer out there today. And whereas stereolithography, you have a vat of resin and it basically pulls the model out of the resin. FDM printers, on the other hand, are similar to what we saw with the RepRap project. It has a blank build area and lays down a layer of plastic. And then it moves up and it lays down another layer of plastic. And it keeps doing that until you have the full 3D model. And so an FDM printer is basically, it takes filament at a certain diameter. Common diameter is 1.75 millimeters or 3 millimeters. It takes that filament, runs it through an extruder. It heats it up, runs it through the extruder, and well, it runs it through the extruder, and then it heats it up, and then through the hot end, and it goes through the nozzle. Um, and the nozzle is heated up to, say, 200 degrees Celsius, which is really hot. And that shrinks, or well, basically extrudes it down to a certain diameter. A common diameter is 0.04 millimeters. So you're going from 1.75 millimeters down to 0.04 millimeters. You can go to zero point 0.1 millimeter, or you can go even smaller. And the size of that determines what the resolution is basically on your print. So the smaller you extrude it down to, the finer detail you can get. However, the print times become extremely long when you get down really, really small. Whereas if you go with a larger nozzle, let's say you go to a zero point 0.1 millimeter, you can print out really, really fast, but the model looks, it doesn't have as much detail. And it's not that good if you're trying to do some sort of artwork or something, depending upon what you're doing. But FDM printers are very flexible with how you want to how you want to use them. Then there's selective laser sintering, or SLS, selective laser melting, SLM. Uh, I think those are used for metal printing, electronic beam melting, EBM, laminated object manufacturing, LOM, binder jetting, BJ, material jetting, or MJ. I'm not going to ever test you or question you on any of those. The main things are know what stereolithography, SLA printers are, and fused deposition modeling, or FDM printers are. Those are the two most popular ones out there today, and the biggest printers in the consumer market. So this website here actually goes over the different types of printers. So we're going to look at it really quick. So scroll down a little bit. And so every printer has various features and everything. Um, 3D printing in a nutshell, here's a guide for it. Scroll down a little bit more. My scroll wheel isn't working that well. Okay, so SLA printers. So there's two ways of actually printing on an SLA printer. This is showing it pulling the model down into the resin. The other way is pulling the model out of the resin. They function the exact same, doesn't really matter, but you basically have your build plate here. This is the model, and this is the vat of resin. And you have a laser which shines here and hardens the laser, or hardens the resin at the specific points, and then it moves. So that's an SLA printer. So it's fast for prototyping, et cetera, et cetera. This is a DLP. same way. This shows it pulling out of there. And it does, instead of just regular resin, it's photopolymer resin because it has to react to the light. Um, Apparently, it was created by a man by the name of Larry Hornbeck back in 1987. And it does the exact same thing. It just hardens and pulls it out of there. FDM printers. This is what my printer, the Ender 3, is. It's an FDM printer. What a lot of the, probably all of the RepRap printers that you can find on that site are FDM printers. They're really easy. They're fairly easy to build. They're really easy to program for and everything else. That's why they've become so common. You basically have, and this is showing three components. You have the nozzle where the plastic comes out, the plastic here or the model, and the bed which actually moves. And this is showing that the bed moves in three dimensions. There are several different ways to do this, and so that's just one way of doing it. FDM printers are the most common out there, I believe. So here's the selective laser sintering. This is for metal printing. And so this is showing that there's the metal powder. It gets moved onto the bed. Laser shines down. This looks very similar to the SLA printer, only instead of being resin, it's metal. And it just acts that way. Selective laser melting, something similar to it drops down powder and then it hardens it. Now, these are not the way that it has to work. It's just this is the way they happen to draw these diagrams. Electron beam melting, so similar process, and laminated object manufacturing. And so what this is doing is it has a roll of some sort of material here that it pulls across, laser hardens it, and then the waste material goes over here. So those are, oh, and binder jetting. This is created by the Massachusetts Institute of Technology. Powder bed printing, inkjet printing, drop on powder. It can be used for ceramics, metal, sand, and plastics. And then there's material jetting, which is wax casting. So I haven't ever seen these other printer types in action or really ever seen them, but they are out there. So we're going to talk about the popular ones. So FDM, or fused deposition modeling. So it's the most popular type of printer for consumers. It works by taking a filament, typically PLA plastic, and I'll talk about the material in a second. Takes the material, pushes it through an extruder. The extruder moves around in the shape of the object at each layer, which is how you build the model. And it just moves up, down. It doesn't typically go up and down unless you're moving from point to point, because once you put down a layer, you can't move below that layer, otherwise you'll happen to go over the same layer. So common materials are polylactic acid, or PLA. It is a corn-based plastic, and it has low odor. It's a very easy plastic to model or create 3D prints with. It comes in 1.75 or 3 millimeter diameters. It's the one that I normally use. It comes in a lot of colors. I mean, if you could think of a color, I would pull it up on Amazon, but Amazon seems to have very limited selections at this particular point in time due to the whole global pandemic. But it can come in all sorts of colors. In fact, looking at my desk right now, I have white, blue, black, pink. I did not choose pink. That was not my choice. Orange. Let's see, I also have wood. It's actually plastic with wood fibers in there. So you can print with it, and then you can sand it, stain it, and it kind of has a look like wood. I have copper, and this is a plastic which has, it doesn't have copper in it, but it looks like a very shiny copper. There's also, let's see, those are all the ones that I have, but you can get PLA, which is reflective. And so, or not reflective, glow in the dark. So when you print there, Well, it glows in the dark. You can also get some which are flexible to where you print it and then you can squish the object, or you can stretch it a little bit. You can also get PLA which has actual metal fibers or metal shavings in there, filings. And that one, when you print it, then you have a 3D printed object that you can then polish because it actually has metal in there. Now, depending upon what type of material you print, if you just print with just the regular solid color PLA, a common nozzle on a 3D printer is made out of brass. And a brass nozzle, that'll last you for quite a while with regular PLA. It's not abrasive. It reacts to temperature really well. But when you get to some of these other materials, especially the ones with metal filings in there, or there's some with carbon fiber in it, or some with nylon. Those are really abrasive, and your nozzle, if you were printing with a nozzle, would last maybe one print, maybe not even one print. So you would have to change the nozzle from a brass nozzle to either a hardened steel nozzle, or there's other components that nozzles are made out of to extend the life of uh, the nozzle, so then you don't have to replace it all the time. But anyway, so that's PLA. Then there's ABS, uh, acrylonitrile butadiene styrene, or ABS. Everybody calls it just ABS because, well, I'm not a chemistry professor, so I'm really bad at pronouncing some of those chemical names. But this is an oil-based filament. So PLA is corn-based, ABS is oil-based. Now, what's the key differences between the two? Well, other than one's oil-based and one's corn-based. PLA breaks down under UV lights. So what does that mean for it? Well, if you print out something, take it outside, leave it outside for a while, eventually it's just going to break down. And so that's good in the sense that we don't have plastic staying around for millions of years, but it's bad in the sense if you wanted to have a cool thing printed off and leave it outside as decoration for something. Whereas ABS, on the other hand, you can print it, leave it outside, and it doesn't break down nearly as quickly as PLA does. ABS also has a odor to it when you print, and that odor puts off or contains what is known as volatile organic compounds, or VOCs. And these are compounds which can cause cancer and they can cause other health problems. And it's not really understood exactly what ABS puts out and how harmful it is yet, but it's probably not a good idea to breathe it in on a regular basis. I mean, 50 years from now, we may be looking back and seeing how dangerous 3D printing is, just because some of these things happen to get put into the air and people were staying by it 24 hours a day. So ABS is one of those where you also typically need to have an enclosure for your 3D printer to filter out the volatile organic compounds. The other thing about ABS is the temperature needs to be fairly consistent. PLA is very forgiving in uh, temperature variations, or if you happen to have a slight breeze in your office where you have the 3D printer, PLA generally doesn't have a problem. ABS, on the other hand, if the temperature varies too much, you start to get layer separation. And that's where, as you're printing, the layer, one of the layers there happens to split and come apart from the layer below it. And that's a bad thing. There's ways around it, but the easiest way is build an enclosure around your printer. You have a constant temperature, you don't have to worry about freezes, and then you don't really have that problem. Now, the pros to ABS, I mean, I already talked about you can have it outside. But one of the things about 3D printing, and it's one of the things which if you 3D print, you just start to get used to, and really it starts to look kind of cool. But when you print, because you're printing layer by layer, you get kind of ridges, which if you think of like one of those 3D hologram plastic things where it has that plastic sheet on top of an image and you move it back and forth and the image moves back and forth, it's kind of similar to that. Now, I hate running my fingernails over it. To me, that's kind of like running your fingernails over a chalkboard, but that's kind of what 3D printing has. Now, PLA, you can get rid of some of those layer lines by sanding it or coating it in a certain material and that sort of stuff, but it's kind of labor intensive and it's not perfect. ABS, on the other hand, since it is an oil-based material, you can you can basically put it into and it's a special device for it. You can do it from home, but it's generally not recommended just because what I'm going to explain next. But basically, what it is you put it in an enclosure, and then you put acetone in there, and you heat up the acetone, and the vapors from the acetone will melt ABS. And you don't leave it in there too terribly long. It's kind of an art form to figure out how long to leave it in there. But the acetone itself will smooth out the print. And then when you're done, you take the print out of there, out of the acetone fog or mist, and you have a smooth, shiny print. And so it's not recommended to do that at home because I think acetone is flammable. And so if you create a mist and it ignites, well, bad things happen. And I am not responsible if you happen to burn down your house. Let's see, next material, polyethylene terephthalate, PETG. PETG is a common material that all of you know of, but you may not actually recognize what it is just from that. PETG is used in water bottles. It's also used in food safe objects. And so you can 3D print a water bottle. Um, Now, that's not entirely recommended um, because the layer lines in an object are really good at holding bacteria. And so you can print all sorts of things, but after you use it once, it would not typically be considered food safe anymore. Doesn't mean you can't 3D print another thing, but you could. You can also get nylon, and it actually has material with nylon bits and pieces in there. And the nylon once you print it, it's going to be really, really strong. And much like ABS, you can have it outside and everything else. So I mentioned the common materials and the pros and cons to those. The disadvantages, you have layer lines that need to be sanded or filled. Printing can be slow. So as you're printing it, the faster you print, the more artifacts you can get in the printed object. And so typically you want to try to print at a slower speed. And the slower speed will produce a better model, but well, it's slower. That's kind of the point of printing slower. So that's one of the disadvantages of FDM printing. So stereolithography, or SLA. It's a fast printing method that uses a resin vat for the build material. So instead of having a spool of filament, which kind of just looks like wire, which is, well, plastic coiled up, this has liquid resin. There's a platform that pulls from the resin. At each layer, UV layer draws the model layer, which hardens the resin. Platform then moves to the next layer. Process is repeated. I already talked about this, so that's why I'm just kind of breezing over it. So the pros of SLA is a very high resolution print, and you get very, very fine detail with next to no layer lines. And some of these things look really, really cool when you print with it. Because it's a resin, some of them are kind of translucent as well. So you can do some really cool things with that. If you wanted to print out miniatures, for if you did any sort of wargaming or Dungeons and Dragons or anything like that, you can print out miniatures with an FDM printer. However, you get layer lines, and it may not be the best. But with SLA, you can print out miniatures, and they will look really good and really smooth and everything else. And you can also smooth a little bit more. Now, the disadvantages is it can be several times slower than FDM. It can also be faster than FDM, and so it's kind of a contradiction when I said it's a fast printing method, and then I also said it can be several times slower. There's several different technologies with SLA, and depending upon what type of resin you use, depending upon how fast you print and everything else, it can be much faster than FDM. It can also be much slower than FDM, and the models are more fragile. So whereas FDM printing, you can print out, and I've seen people who have printed out uh, clips to hang shells on a wall, or I have printed off a clamp. It's all one piece, and it's just a clamp. It's actually kind of cool. Uh, NASA, they have actually designed and released, they open sourced it, a, um, a 100% 3D printed ratchet wrench, and it's all one object. You print it as just one thing. In fact, I should print one of those off just so I have an example of it. But anyway, they have it because up in space they have 3D printers up there, and if an astronaut needs some doodad printed off for whatever they're doing, well, the 3D printer allows them to rapidly print off whatever it is. And so the ratchet is used for that, and they can print off a tool to assemble other things. Whereas SLA printing, you can print off something very similar to that, but it's not going to be nearly as strong as a plastic. And it's just because it's resin, and the resin's just not going to be as strong. All right, so those are the two common printing technologies. So let's go ahead and talk about a couple of notable 3D printing. So OrthoPrint. So this guy by the name of Amos Dudley, he wanted to see if he could 3D print teeth straighteners. He went to the orthodontist, and he was quoted, or he figured out how much it would actually cost to get his teeth straightened, and he didn't want to do that. And so he decided to see if he could do it. And there is a warning up here. He should have it in bigger letters. Do not attempt anything he has written here. Do not attempt anything written here. No liability. So don't do this. I mean, the orthodontist has actually gone to medical school for a number of years, and they have liability insurance and everything. So if they screw something up, then, well, you get a lot of money. If you screw something up by doing this, well, you screw something up. So anyway, so this is an example of his mouth, and this is what he wanted to print out. And this is actually, I think this is a printed object that he did. Um, so he took molds of his mouth, took it into 3D modeling software, and figured out how much the teeth should move at what rate. And so then he printed off 3D models of it, of each step of the way, and then took these 3D models into a vacuum former. And what that does is you have the printed 3D model here, and then you have plastic over it, and it heats it up and forms it around there, and you are left with a formed cast of that 3D object. And so he used these. And so you can see this. This is a before, what it looks like, and there's the one tooth which is sitting out more. And this is an after image, and you can see that tooth is more in line. And so he was able to successfully straighten out his teeth with 3D printing. Now, he was an art major, I believe. He was not a orthodontist or a dentist. Um, he's a designer. He doesn't actually want to release the individuals because he doesn't want copycats. And he just did it just because, well, it's cool, and he also wanted to save money. So that's one type of printing. Um, Jay Leno printed parts for his car, and he was one of the first consumers to start to get a metal 3D printer. And this website, this is 3D Systems. Now, if you think back, well, roughly half an hour ago, that was the company that Charles Hull created. And so this video, we aren't going to actually watch it, but this is a promotional video kind of put out by 3D Systems where Jay Leno talks about them scanning in and modeling parts for his cars, which are all custom made. And it's a really cool article. I would encourage you to read it and watch it. Local Motors 3D prints the first car, and so that's a short video. And then this right here. Now we aren't going to watch it, and I'm going to mute it because there's music and talking and everything. Mute. And well, there's an ad, so we're going to get past this ad in a second. And this is 3D printing a home. Now, pausing this right now, this is very, very similar. In fact, it's identical to how an FDM printer works. You have your extruder here. This happens to be concrete, but it's putting out a layer at a time as it goes. And you can see the individual layer lines here. Each one it goes over and it just happens to go out. Home like this can be built in 24 hours. Now, this doesn't include all the electrical and everything, but they're just talking about the walls and the manufacturing. And so this is the printer in action. And literally that's all it is. And that's really all a 3D printer is you just extrude out some sort of material into the shape that you want to print. So I also encourage you to watch that video. It's relatively short. It's only a couple minutes long. So now, after talking about all the cool things about 3D printers, what about controversies? Well, Defense Distributed, they were the first company to create a 3D printed gun. And you can watch that video. That video is 8 years old now. But basically, they decided to design and develop or design the parts for a firearm. And once they designed that, they released it online. And once they released it online, well, government started to get concerned about it, and I believe the U.S. Department of Justice or State or somebody sued them and got the plans removed from the internet. Well, the problem is that the plans were already released, and so people got it, and then they shared it everywhere. But Defense Distributed, they pulled down the plans, and it was down for about 5 years until finally I think it was Department of State or Department of Justice, I can't remember the exact one, basically said, all right, you can go ahead and put them up on the internet. So they put them back up on the internet. Well, then some individual states decided to sue them to bring it down. I think the state of Washington sued Department or Defense Distributed, and so it was up there for I think 24 hours before they got a court injunction to get it pulled down again. But 3D printing guns is one of those things which is kind of in the legal gray area. It is, and I'm talking about in the US right now. In the US, you can manufacture your own firearm from hand. You do not have to get a firearms license, but you cannot manufacture a firearm and then sell that or give it away or do anything other than have it yourself. If you do, then you have to get a firearms license. Defense Distributed is distributing plans on how to basically manufacture a firearm, which is kind of a legal gray area because in order to manufacture a conventional firearm, it requires specialized equipment and a fairly sophisticated mechanical aptitude because you have to have a CNC machine, you have to have a certain amount of metal, you have to know how to um, make the object, and it's not something that anybody off the street can do. However, if you can 3D print a gun, 3D printing is one of those things that, well, I have a 3D printer. Anybody can buy a 3D printer, and it's really not that hard to get started with it. And so now suddenly there's this fear that anybody can have their own 3D printing gun and they're traceable. They're called ghost guns. And it hasn't really manifested that way yet. I don't know if it ever will, but that is one of the big concerns is what if people start 3D printing their own guns? Another controversy is 3D printed organs. What if you're able to, I mean, it's on the surface, it sounds like a really good idea of, well, if you can have a machine create a replacement liver, then we don't have to worry about all the people who are on the donor list because, well, we'll just 3D print new livers. However, the problem is, at least at the current technology, you can 3D print certain components for an organ, but how do you get the body to not reject that? And so you have to use some of their own cells or even stem cells, and there's a lot of controversy between research into that. Um, what about who owns the copyright and how does that fall into intellectual property? So this is going back a couple of weeks when we talked about copyright. If I design a 3D object and I print it, do I own that? What if I design my own 3D object? So if somebody owns a copyright to something, um, I can make a drawing of it. That falls under fair use. I can make a 3D model of that. That falls under fair use. Can I make a 3D model and then print off my own 3D model? Does that fall under fair use? Who actually owns that object that I created? If I do violate copyright and I print off an object, does the copyright owner own that object even though I printed it? It's one of those which it's not actually a clear-cut, clear answer. 3D printed drugs. So 3D printing, if we are talking about just um, building 3D objects, can't really print a drug. However, technology is advancing all the time. What happens when there's a printer out there which can take several different chemical compounds and print out a drug, either legal or illegal drug? So that's one of those which it may come to the point to where the general public has access to these printers and these individual chemical compounds. And what happens with law enforcement and if you happen to print out an illegal drug or even legal drug? Chemicals released during the printing process. And so I talked about volatile organic compounds, which happen whenever you heat up something or it happens all the time. But with 3D printing right now, there's not a lot of research in what happens when you print. And there's people out there which are getting these 3D printers and they have it right next to their bed and they sleep while it's printing. Or there's people which have kids running around while it's printing. How do we know that whatever they're printing with cause, well, cancer? Also, there's no, eh, whenever you manufacture food and sell it, the food has to be tested and has to go through an entire process. It has to be certified by the Federal Food and Drug Administration. And that basically says that it is generally safe for human consumption or it's safe, that sort of stuff. 3D printing doesn't have to go through anything like that. You can have a company in China which manufactures filament, and they may end up contaminating that filament with some other compound. And they don't have to list what compounds are in the filament. So how do we know that all the compounds which make up the filament and all the 3D printing is 100% safe? And it's one of those things which things will have to, laws will have to get made and all sorts of certifications and everything eventually. Food safe prints. I also briefly mentioned that with PETG you can create your own water bottle. But that print is generally only safe for the first use. And even then, depending upon what chemicals are in the actual plastic, it may not be safe for the first use. So food safe prints, or even printing out a whole bunch of stuff and selling it and marketing it as food safe, is kind of a gray area and probably not even legal. Um, Reliance on plastics. Well, FDM printers, they print with plastic, and plastic is out there, and it's a sad image to see the oceans getting filled up with plastics, or if you go to the landfill and you see all the plastics in the ground, it's just not a good thing environmental wise. But with 3D printing, well, you're printing plastic and you're printing with plastic. So it's kind of increasing our reliance on plastics, and that's not necessarily a good thing. Now with PLA breaks down a lot quicker than ABS. It doesn't break down super quickly, and PLA can still be around for a while, but it does break down quicker. However, there's a lot of other 3D printing components out there which do not break down as quickly. And so 3D printing does kind of increase our reliance on plastics, which is not necessarily a good thing. Um, and let's see, I have a printout here. Let's see, 3D printers are energy hogs, which, so this is an article from Tech Republic. Um, so they say that 3D printers are energy hogs, which may be true for some 3D printers. My particular 3D printer, it's a Creality Ender 3. It has a 360 watt power supply, which is the max amount of wattage that it can consume. Well, actually, it can go slightly higher than that, but basically, it's rated for 360 watts. On average, it probably only consumes about 100 to 150 watts, which, if we calculate out how much power that actually is using, if we were to run my printer 24 hours a day, 365 days a year, so if we ran it every day for an entire year, my printer would probably, and we figure that electricity is about 10 cents to 11 cents per kilowatt hour, because that's how electricity rates are normally measured in. My printer would probably cost me about $120, which isn't that much, which means that it's not really consuming that much power. I mean, my computer, which I'm streaming this on, is on all the time and consumes way more power than what my 3D printer does, just because, well, it has much better components. A standard light bulb, if you have standard 60 watt light bulbs in your house, now everybody should be on preferably LED or CFL light bulbs. But if you still have old incandescent light bulbs, which were 60 watts, if you leave two light bulbs on, that's consuming the same amount of power as what my printer is consuming while it's printing. So they can be energy hogs, and some printers are, but my printer isn't necessarily an energy hog. Gun control loopholes, um, responsibility of manufacturers. So if you print out something and you sell it, and whatever that was happens to break and injure somebody, are you responsible for that? Well, that's an unknown question. National security risks, safety of items that come in contact with food. I think I've already touched on all of those. So those are the controversies that I can think of off the top of my head. I'm sure there's other ones out there, and as a thought experiment, I encourage you to think about why 3D printing may or may not be good or bad, and what could be done to try to make it better, and what technology is out there, and what technology may come to be just from 3D printing. So that is, I believe that's my last slide. Let me double check. Yep, that is my last slide. So I will go ahead and end this here for today. Like I had mentioned, I was unfortunately not able to get streaming set up from my Chromebook. I hope to be able to record my 3D printer and give a short 10-minute demonstration of how the 3D printer actually works, because if you have never seen a 3D printer work, it's fascinating. Like I'd mentioned before, I can sit there for an hour watching it print because it's cool. And I mean, it's not really boring, but it's cool. So I will hopefully do that. And uh, other than that, I will talk to you guys next week. And so I hope you all have a great weekend. Stay safe and stay healthy. And I will see you next Tuesday. Thank you.